Okay, thermoelectric coolers. An example of one. 3 centimeters by 3, roughly. So maybe an 1/8 inch thick or so. These do work both ways. If you put current into it, it will pump heat from one side to the other side, depending on the polarity. They work both ways. Conversely, if you apply heat to one side and remove heat from the other side, it will produce a current across it. I have here, obviously, a multimeter set of reed volts. Both sides of this are pretty much at the same temperature, so we're seeing 0 voltage. Also have down here a small motor. It's actually a real motor from a high-end cassette deck. Those work at a fairly low current, so it's a good one to have for this demonstration. I put a little flag on it just so it's easier to see that it's turning. Notice the voltage on the meter right now is pretty much null. If I just the heat of my fingers on one side of this gets it up to almost 50 millivolts. It's kind of impressive. So, but yeah, up the ante some. Now I'm going to use this flamethrower and heat one side of this. You'll see the voltage climb and you'll see the motor begin to turn. Does not take very long. That's almost up to 1 volt. Gotta let it get there. Yeah, maybe not. Ideally, the problem here is both sides are heating up. What drives this is if one side is cold and the other side is hot. And with me just putting a lighter on it on one side, the whole thing heats up eventually. But in my view, to get that kind of energy out of something so small, I mean, it's hot. I'd say maybe this is about 50 degrees C. But even now, all I'm doing is cooling down the bottom side, and it's enough to turn that motor. So yeah, you will get usable energy out of these thermoelectric coolers, TECs. They're not real cheap and they're fragile as hell. They take compression fairly well. They do not take shear well at all, and also they're open in between the top and bottom, which are some sort of ceramic material. And it's important that you keep condensation from building up. Applying power to these things, one side will often get cold enough to produce condensation at the very least, and sometimes they'll freeze, frost up. You want to keep that away from the innards, because the corrosion will happen and it destroys them. They're nifty things. Like I said, they're not cheap, but they really do, as promised,